Hey guys, this is just a quick video on calibration of these NTC temperature probes. So if you're looking at the RAPT temperature controller, or you've got the BrewZilla for that matter, or you've even got the RAPT fermentation chamber, this calibration process in the software is very, very similar. So you'll notice with these devices, they have a wide probe. So if you look at the BrewZilla, that's at the bottom of the boiler. Or if you look at the fermentation chamber, that's on the side of the fermentation chamber. Because we use similar firmware across the devices, the calibration process is pretty much identical. I should also say that this particular video on calibration is calibrating the wide probe here. If you've got a Bluetooth device, so let's say for instance, like we've got a Bluetooth temperature thermometer, or in this case, I've got a Bluetooth probe just sitting on the, Bluetooth pill sitting on the desk here. Now, if this is giving out a Bluetooth signal, I can also pair this with the temp controller and use that as the sensor, as the temperature sensor sitting inside my fermenter. However, this calibration video is not how to do that process. You'll have to go to another video where I'm going to show you how to do that and pair the pill with the temp controller. And the reason why we don't do calibration on the controller for the pill is because the pill needs to give out a calibrated temperature reading. So when it's giving out that Bluetooth beacon, which this device is picking up on, the Bluetooth beacon has to be calibrated, which means you have to go into the firmware of this device. So you connect to the pill with your phone and then basically put in the calibration figure. I should also say the pills rarely require calibration because they use an onboard chip. There's no wiring, so there's no resistance of the wire to take into consideration or anything like that. And it's also a digital type probe, which is on board. So look, it's highly unusual that you need to calibrate a pill, but I will cover that in a separate video. So for this wide probe calibration process, I'm just going to quickly explain to you how the calibration works in the settings here. So if you go into the settings here, you click on that and you can see in here we have these NTC readings here. So this is going to be a bit of mumbo jumbo for some of you guys. Some of you technical guys will probably understand it, but we've got the NTC beta, NTC reference, and the NTC resistance. Now, look, if you've done a lot of testing on this probe yourself and you're an engineering type of guy, then probably you can go in here and you can also plug in these figures directly into the NTC beta and NTC reference temperature and resistance. However, that's going to be too complicated for the majority of you people out there. So what I'm going to say is just go into calibration point 1 and 2 here. So that's in the settings. See calibration point 1, calibration point 2. Really, really simple. For these two calibration points, let me just briefly explain how they work with a graph. So to give you a better idea on how the controller is actually calibrating and how the sort of, I guess the mathematics is working behind the scenes, I've got a little graph here. So basically any NTC probe has a similar type of calibration process because the NTC probe is obviously not picking up temperature directly. It's basically picking up on a resistance and it's converting this to a temperature. And it does that using a sort of curve, something like this. Now, when you buy an NTC probe, it comes with a curve already, published by the manufacturer of the probe itself, and that's what you generally go off. But NTC probes can have a little bit of error in there, but if you do this calibration process well, you can actually get very good and accurate, reliable results with an NTC probe. So if you do a single point calibration, so let's say if you guys only put that one calibration point in there, we can't actually calculate the curve shape at all. All we can do is put in an offset. So let's say, you do that single point calibration and you work out that the temperature's off by, let's say, I don't know, 1 or 2 degrees or something like that. All it can do is shift the curve up or down. So it'll do something like this. So let's say that's the standard curve and you calibrated it. It'll basically look like this. So this can be the calibrated curve like that. Notice how it hasn't really changed the shape of the curve because you've only given us 1 point. It can't actually do anything. It can just move it up or down like this. So, that's great if you've calibrated near the point, where you're actually using the device. So if it's only got a narrow range, let's say for fermenting, you're, calibrating at 18 degrees and you've got a very accurate source of the temperature that you're relying on to put in that calibration point, and you know that that's exactly 18 degrees, then you could just move the curve up and that will probably give you good results within a small range. If you're using the device over a wide range of temperatures though, it's really hard to beat the 2-point calibration process. So if you go to a 2-point calibration process, you can then start to actually, change the curve itself. So this is the standard probe. Let's say we've done 2-point calibration process. We can basically create another graph like this, but instead of just moving that up and down, I guess, we can look at it this way. We can basically say we're going to create a whole new curve which looks something more, I don't know, like that, for an example. So it goes all the way out here, and maybe that's like actually the more, accurate figure. Notice how it's got a different shape to the curve. It's stretching it, sideways, for instance, not just moving it up and down. So that's essentially how it works. So 1-point calibration just puts in an offset, which will just shift this up and down like that, and that's all it's going to do. But then 2-point calibration will actually plot a whole new NTC curve like this. Now we'll put in the formula in the comments below so you can understand how it works behind the scenes as well for those people who are a bit more technical. Yeah, if you've got any other questions on the process, of course, just ask us in the comments below, and we'll put more information in there too. Now, the ideal scenario is we're calibrating the calibration point 1 and 2 at calibration points which are as close to the usage points to where we're using the actual device. So for instance, I've got this temperature controller. If I'm going to use this for fermenting, I'm typically going to be crash chilling at around about 0, and then I might be fermenting at the hottest temperature at, let's say, I don't know, maybe 25 degrees Celsius. So, if I had the ideal case scenario and I knew exactly what 25 degrees Celsius was, I'd be putting calibration point 2 at 25, and I'd put calibration point 1 at, ice water. Now, in reality, if you guys don't have a high accuracy probe, then you're just going to have to use the freezing point of water and obviously the boiling point of water, which are the two easiest points of calibration because they're very known, even without having to go out and buy an expensive thermometer, for instance. So with calibration point 1 here, I'm going to do that one first. So I've got this probe sitting in the ice water. Now notice this plastic cup here is absolutely chock-a-block with ice. I couldn't fit any more in the cup. I've already had the probe sitting in there for a while. So what I've got here is 0.00 degrees Celsius. And what I'm looking for is the ADC reading here. See, it's kind of stabilized at 3539, and it's been sitting there for a little bit now. You might get a slightly different result. It just depends on the cable. So for instance, if the cable starts to get a bit old and damaged or something like that, you might have a slightly different resistance on the cable and therefore have to do this process again, unfortunately, but that is just, I guess the limitations of using an NTC probe, I suppose. So as you can see, it's sort of like, or if you make an extension to the probe, some people are extending the wire, you might want to do this process again. But you can see how it's very, very much stable. So it's at 3541, barely changing at all. So I can hit enter, and that'll save that calibration probe reading there. And as you can see, it's already got that reading there saved at calibration point 1. Now, because I've only saved that point now in there, it can only basically save that as an offset. To really work out, that complete graph and either stretch the graph in the X or Y direction, what you really need to do is put the second calibration point in. So at the moment, it's just an offset. So a simple level of calibration will make it more accurate simply by putting 1 point in. However, I'm going to go down to the calibration point 2 here now. And what I'm going to do is basically save this one as well, but this time I'm going to use boiling water. So I'm going to take it out of there, and I'm going to plug in my kettle, and I'm going to get this actively boiling with water. The other thing you need to know with a kettle though is you got to look at your altitude above sea level. Now I'm in Noble Park, okay, shooting this video. So let me just change the angle of the camera here. So I'm in Noble Park shooting this video, and I know that in Noble Park, my boiling point of water at 40 meters above sea level is approximately 99.89 degrees Celsius. So what I'm going to do is, instead of having this temperature setting at 100 degrees Celsius, I'm just going to go down here to go 99.9, for instance. Look, not a lot of difference we're talking about here. If you're a long way above sea level, maybe you're living up in the hills in the on, you know, base camp or Mount Everest or something, you're definitely going to be wanting to change this number. But really, for most of you guys, even if you did it at 100 degrees Celsius for boiling point, it's probably going to be fine anyway. But just thought I'd mention that just in case some of you guys living up in the hills. Anyway, so I've got that probe sitting in there. It's fine to just immerse the probe in liquid like that in boiling water. As long as the boiling water is not exceeding 120 degrees, this probe and cable will be fine. So I've got that sitting in there. Let me just fast forward this video because it's pretty boring watching water boil. Okay, that's great. You can see that I've definitely hit a boil here, but more importantly than hitting a boil here, my ADC reading has really started to plateau. So as you can see, it's 290 or 289, pretty much, you know, bang on, and it's sort of hovering around there. So I'm gonna hit enter now and save that point. And now I've finished the 2-point calibration. So that's all you have to do. It's really straightforward. And you know, once you've got that in there, it'll automatically calculate these NTC figures for you. So as you can see, these have now changed and it's redone that calculation. So anyway, that's it. If you've got any other questions, just put them in the comments below. And you know, if there's any other settings on here which you'd like to get more advice around, yeah, just put it in the comments. We'll be more than happy to make another video on that as well.